next session on Advanced ANSYS Workbench tutorials. In this session, we will analyze the globe valve for its explicit dynamic analysis. We will do the same analysis which we have done using the static structural module. Here you should get a dynamic result of the valve using the same boundary conditions. So we will go for the explicit dynamics module. Double click. First, we'll go to engineering data and double click. We will be using the same three materials that we have used in static structural module. So the first material we will choose from engineering data sources itself. We'll go to general materials. Stainless steel is what I'm going to bookmark. So just click on this plus sign. You can see here there's a bookmark. Next, I'll click on engineering data sources again and come back to the screen. Here I'm going to add two more materials, brass and bronze. So it's written here, click here to add a new material. Just click here and write brass as the first material. The properties that I'm going to give are density. In kg per meter cube, the value is 8490. Again, I'll click on brass and here I'm going to choose isotropic elasticity. So I'll double click on it. I'll go to Young's modulus. The value is 97 gigapascal. So I'll change Pascal to gigapascal. And here I'll write down 97. Value of Poisson's ratio is 0.31. So we have created the material brass. Next, here again I'm going to click and write bronze as the next material. I will click on density, double click. I'll add the property. Density is 8410 kg per meter cube. Again, I'll click on bronze and double click on isotropic elasticity. The value of Young's modulus is 138 gigapascal. So I'll change Pascal to gigapascal. And here I'll write down 138. Value of Poisson's ratio is 0.42. So now that we have created both the materials, we will go to project and update project. Once this is done, we'll go to geometry and right click. Import geometry. I have the valve made, so I'll directly import the valve geometry. Then I'll go to model and double click. Once this is done, we'll go to geometry here, click on the plus sign, click on the part and change the assignment to say stainless steel first. Then I'll go to mesh and I'm going to use the default size which is given here and generate. You can reduce the size of the mesh. I'm using the student version, hence I'm using the default mesh itself. Once the meshing is done, we will go to Explicit Dynamics A5 and here you can see beside analysis settings there's a question mark. So click on it. There is some data which has to be given, hence there is a question mark, otherwise there will be a green tick. So I'll come down here to the details view. Here I'm going to give the end time which is 0.001 second. Then I'll go to Explicit Dynamics A5, right click and insert fix support on this face, apply. Again I'll right click and insert fix support on the other side, apply. I'll right click and insert pressure on the internal surfaces. Click on apply. The value of pressure is 50 megapascal. Again, I'll right click here and insert force at this top end. Apply. I'll define by component, not vector. The direction is y. So along the y-axis, I'll give a force of minus 50 Newton. Next, I'll go to solution and right click. I'll insert deformation total. I want to see the deformation along the x-axis, so I take up direction deformation. Again, I'll go to solution and right click, insert strain equivalent. Also, I'll right click and insert stress equivalent. I'll right click, insert stress tool, max equivalent stress. Then I'll go to solution and solve. We have got the results, so we'll go to total deformation first. Here you can see the maximum deformation in red color is 0.11514 mm. Minimum is 0. Now the deformation is very less, which means 50 megapascal is a very low value, but I have used the data that the maximum pressure which is applied on a globe valve is 50 megapascal, so I'm not increasing the value here. Definitely if you increase the value, there will be some kind of failure in this valve, but that's the maximum value, so I'm not increasing its value and testing. Next, we will go for directional deformation. The maximum value is 0.10692 mm, minimum is minus 0.1127 mm. If you want, you can animate and check this result. The next is equivalent elastic strain. Maximum is 0.0029, minimum is 9.965 into 10 raised to minus 6. Now the color will indicate where it is max and where it is min. If you still can't figure out, here you can see there is an option of maximum and minimum. Both will get highlighted. If you don't want to see them, just click on them once again. Then we will see the equivalent stress, which is maximum of 547.97 megapascal. You can see the color red is here. Minimum is 1.3887 megapascal. You can see these colors are blue. Now we can get the value of safety factor here. The maximum is 15, which is your safety factor. So your part will remain safe there. So in these sections, you can see these are highly safe section. Now red color is indicating highly unsafe section. So the range of this red color is from 0.3775 to 1. Now if you use this option of probe and you run the probe over this body, you can see in the red section the value of safety factor. Now it is more than 0.5 in certain cases, but it is less than 0.5. So if it is unsafe, what you can do is you can reduce the value of pressure and you can test. Now we have tested for stainless steel. Next we will change this material to brass. Now if you want to find the value of safety factor here, so we'll go to solution A6 and solve. So you can see the solution is not obtained. The reason is for calculating safety factor, we need to give the value of yield strength and ultimate strength of the material. Now since I cannot add those values, I'll just delete this one. I will leave it to this only and I will solve the project once again. So now you can see the solution is obtained for the material brass. We'll go for total deformation. The maximum deformation is 0.2822 mm. You can animate and see the pattern of its motion will be the same as that of stainless steel. Then we'll go for directional deformation. The highest value is 0.2594 mm. Minimum is minus 0.2624. The equivalent strain maximum is 0.0104 and minimum is 2.199 into 10 raised to minus 5. Stress is 996.36 megapascal. Now the stress generated is really high for this body. So we will now change this to bronze and solve once again. We'll go to solution A6 and solve for the third time. Once we have got the result, we'll go for total deformation of bronze. As the material for globe valve, you can see the maximum value is 0.189 mm. Directional deformation, the maximum value is 0.152 mm. Minimum is minus 0.14724. The strain is really less, 0.0051 is the maximum value, that too over here. Minimum is 1.613 into 10 raised to minus 5. We'll see the equivalent stress. It is 697.15 megapascal. Maximum over here, as you can see, is red in color. And minimum is 1.3099. So you can see that using bronze will be the best option if you are talking about the resistance to this amount of pressure, because it is showing the least stress and it is the safest. Then you can think about the other two materials. It actually depends on how you want to use it for your application and what is the criteria on which you want to decide. So with this, I end the session. I hope you have understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.